Okay, so this is the at-home notes for 3.3 exponents and log equations. We're going to be using these properties. I've already given you this one last week, especially for you guys that didn't have a base log button on your calculator. You can use this one, which they're the same thing, except you can use natural log instead of log, but it's the same thing. It's natural log of the big number over natural log of A. Over here, this side right here is how you go. This part is called condensed. This is condensed and this is expanded. You're supposed to be able to change from condensed to expanded, and that's all the way down here, and the same over here. This left side's condensed, the right side's expanded. You need to be able to do both to these, either condense them if they're like the right side or expand them if they're left. So this first property says if you got the log base A of something multiplied together, you can rewrite that as the log base A of the first thing plus the log base A of the second thing. If they're dividing, see, multiplication is add. If they're dividing, anything on the bottom gets a minus sign. So it's log base A of the top minus log base A of the bottom. Now, if you were to have two different things on the bottom, let's say it said log base A of U, we'll say U over VW. Not a very good VW, that pen kept writing. VW. And if you were expanding this one, this would be log base A, and since U's on top, it's positive log, but then you'd have a minus log base A of V, and then W's on the bottom as well, so that'd be minus log base A of W. So anything on the bottom puts a minus in front, anything on top's positive. And then the last one is if you have a power, you're allowed to move a power after the log base A of something to a power. You can move that power to the front. So that power becomes n log base A of U. I think that's a U. And these are exactly the same rules if it's in natural log form. So the log form and the natural log forms are the same. So we're going to use that stuff on the homework today. So this up here says rewrite these, and I'm only going to do these first 6 and 8. Rewrite these in both log form, doing log form, common log, which is log base 10, or natural log. So you're supposed to, again, you go log, and I guess I should just do a regular L. I wrote a cursive because it sometimes looks like a 1. Log of 4 over log of 1/5. And again, just like this one over here, you can also write that as natural log of 4 over natural log of 1/5. Doing the same thing here, it would be log of x over log of 2.6, and doing it in natural log form would be natural log of x over natural log of 2.6. Now, part 10 over here says using change of base formula, evaluate the log. So you're supposed to do log of 12 divided by log of 0.4. And you're going to type that in your calculator. So if you type to the number to the left of the 7 is log, and if you hit log of 7 divided by log of 0.4, and hit enter, you get negative 2.124, negative 2.12, round it to 4. We're going to 3 decimal places. Same story for the others. Now you could hit the log base and type this all in at one time. Oops, I did the wrong place. That's not that answer. That's this answer up here, negative 2.124. And you do this the same way. Down here for number 14, these, it says using properties of logs, write the log in terms of log base 3 of 5 and log base 3 of 7. So this is the division one, so that is this one. So I get to write that as log base 3 of 5 minus, and I probably should put parentheses there, log base 3 of 7. Now, if you have 175 here, you got to get this all in terms of 5s and 7s, or 3s too. So you should take 175 and factor that. 5 goes into this because it ends in a 5. So 17 divided by 3 is 5 is 3, and that'd be a 25. So this also is 5 and times a 7. So that means that this equals log of 5 times 5 times 7. In other words, 175 is also equal to 5 times 5 times 7. which means you can rewrite this as log base 3 of 5 times 5 times 7. And then this means we're going to use this one where you're multiplying. So this should equal log base 3 of 5 plus log base 3 of 5 plus log base 3 of 7. These two are like terms, so you get one of these plus another of these, and you can simplify that to 2 log base 3 of 5 plus log base 3 of 7. So that would be the most simplified term. Another way we could have got this same answer right here is, since we have 5 times 5 there, we could also write this as 5 squared. We could have written it as log base 3 of 5 squared times 7. So that means this could be log base 3 of 5 squared plus log base 3 of 7. That's a plus because they're both multiplied. And then you get to take the exponent. Using this bottom one, you get to take the exponent, move it to the front, and you get 2 log base 3 of 5. 3 of 5 plus log base 3 of 7, which is the same thing I got the other way. So there's more than one way to do these. I'm going to skip 18 because you would first factor both these and get them all down in terms of 3s and 7s, and same story here. So we're going to now go over here to 22, and something you need to know about radicals. A square root or a radical and some root, we'll call this root r, the r root of b to some n power. You can rewrite that and put whatever's inside the radical b, and the power n that's with it goes in the numerator, and the root part goes in the bottom. So you can rewrite this with a rational exponent. So the first thing that I would want to do on 22, I probably should have read the directions. I guess I could do 20 also. It says use property of logs, find the exact value of the log expression without using a calculator. So what you're supposed to do here is break 125 down. So 125 is 5 times 5 times 5. So we can rewrite this as the log base 5 of 1 over 5 to the 3rd power, which means this is log base 5 of 1 minus log base 5 of 5 to the 3rd power. Okay? And then you're supposed to know from the properties we had earlier that log base anything of 1 is 0. We're going to bring that 3 to the front, or we could just leave the minus there. We know log base 5 of 5, these things cancel each other out, and that's an old property which is also 3 comes down, or we could have moved the 3 to the front, and this is 1. But 0 minus 3 is negative 3. Coming down here, using this thing I told you up here about the radicals, is the first thing we would want to do is rewrite this as log base 2 of 8 to the 1/4 power. Now we're going to move that 1/4 to the front, so that's going to be 1/4 log base 2 of 8. And then I'm going to make this 8 2 times 2 times 2, which is 1/4 log base 2 of 2 to the 3rd power. So we're supposed to know these cancel out, and that's the power. So this would be 1/4 times 3. This is the old properties. And this would equal 3/4. That would be the answer for 22. This one, again, that's a radical. So this is going to be the natural log of 1 over e to the 1/2 power, because when there's no root there, that's a 2. And when there's no exponent, that's a 1. So again, using that, that's where the 1 over 2 comes from. So this is equal to the natural log of 1 minus the natural log of e to the 1/2. And we got a minus because that's on the bottom, just like this is on the bottom, using this part. And then we're supposed to know that the natural log and e cancels each other out, and the natural log of 1 is 0. So I get 0 minus 1/2, which is negative 1/2. Coming down here to negative 27. As soon as I see a negative in here, just like in class, you're not allowed to do a log of 0 or a negative. This does not have an answer. No answer, because negative 27 is not in the domain. Negative 27 is not a possible value in the domain. Not in the domain. X can't be that. Coming over here to this one, again, we got a 2 in front. Natural log and e cancel each other out, so that's 2 times 6. Then we got a minus. Those two things cancel each other out, so that's a 5. And I get 12 minus 5 is 7. Number 30. Come up here and do number 30. We got log base 4 of 2 plus log base 4 of 32. This plus can be condensed to log base 4, and we can rewrite this as 64. Now 64 breaks down to 4 to the 3rd power. You can break 64 down into 3 4s. 4 times 4 times 4 is 64. And the log base 4 of 4 means that these cancel out and your exponent's your answer. And let's do this last one here. Now this one's kind of a tricky one. There's a couple ways I can do that, but I'm going to say this equals x because I think this is the easiest way to do this. And then I'm going to find x, but I'm going to change this from log form into exponential form. So base stays base, and the other two play switcheroo. And then I'm going to factor 8 down. 8 is 2 to the 3rd to the x power, and 16 is 2 to the 4th. Well, you're supposed to know that if you have a power to a power, you multiply those. So this is 2 to the 3x equals 2 to the 4th. And then this is one of those 1-to-1, since the bases are both 2. You can set the exponents equal to each other and solve. So x would be 4/3. This would be our answer for this problem. So that's how you do the at-home homework. I hope you have a great day, and I will talk to you next time.